Sorry, my Bluetooth disconnected, so I was in the middle of completing problem number 12. I was finding the length of CD, so I had the square root of 3 minus 1 squared plus negative 3 minus 1 squared, and that's going to give us 2 squared plus negative 4 squared, and that's the square root of 2 squared plus negative 4 squared, so that's going to give us the square root of 20. So because AB and CD both equal the square root of 20, we know that those sides are congruent, meaning that it is an isosceles trapezoid. So yes, A, B, C, D is an isosceles trapezoid. Okay, so that is problem 12. What I did as a recap, because unfortunately, like I said, the video stopped because my Bluetooth disconnected from my headphones. BC and AD, we found the slopes and determined that BC and AD had a slope of 0, meaning that they were horizontal or parallel to each other. And then we had to find the length of CD and AB, the non-parallel sides. And when we found the length and determined that they're both negative 20, or sorry, the square root of 20, we determined that they were congruent. And how we found it was using the distance formula that told us the distance of A to B and C to D. So that is problem 12. So now I'm going to work on problem 24 with you. All right. Sorry, I was just getting the problem situated. So we have a kite for number 24, and it wants us to find the length of NR. So essentially, this kite has P and Q being congruent and P and N being congruent as well. Q and M is congruent to M and N. So it wants us to find NR. So it wants us to find this portion right here. I'm just going to label that as X. According to properties of kites, the diagonals form a 90-degree angle. So now, in order to find NR, we're just going to look at the triangle that is formed by R, M, and N. And we have 12 right here, X for the unknown length, and 15. So we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So the two legs squared equals the length of the hypotenuse squared. So I'm just going to go x squared for a, just label this a, b, and c, plus 12 squared equals 15 squared. So x squared plus 144 equals, I think that is, let me see, 225. I was going to say 225, I just didn't want to give the wrong. solution. So in order to solve for x or for a, we're going to subtract 144 from 225, so x squared equals 81. We take the square root of both sides. X is going to equal 9. So we just discovered that the length of NR is equal to 9. So this length right here is equal to 9. All right, so now we're just going to look at problem 33, and then I'm going to post the rest of this lesson to my YouTube channel, and then I will go over the unit review for Unit 9 today and have it posted by tonight, if not early tomorrow morning, but I figure I can definitely do the unit review. It'll take a couple hours, and I can load it up to YouTube tonight. So for 33, we have a trapezoid, and it is WX, Y, and Z. And we have diagonals, and then the intersection of the diagonal is P. And it says that the measurement of angle WZY is equal to 4x plus 10, and it says that the measurement of angle XYZ is equal to 5x minus 5, and it says find the value of x so that WXYZ is isosceles. So we want to find x so that WXYZ is isosceles. So we are going to first label what is known. Once we do that, then we can begin the problem. So it says WZY. So this entire length, or this angle right here that I just drew, is equal to 4x minus 10, or plus 10, 4x plus 10, and the measurement of x, y, z right here is equal to 5x minus 5. So in order to do this problem, what we are going to do in order to solve for x, for an isosceles triangle, according to, I want to find in the book the actual example so that you can refer back to it. Okay, I found it. It's theorem 13.19 on page 839. So if you want to find an example of the theorems, it's on page 839. In order for an isosceles trapezoid, or a trapezoid to be an isosceles trapezoid, we need to have either the bases, those angles, be congruent, and the top angles be congruent. However, since we don't know angle W or angle X's angles, and we know Z and Y, or basically WZY and XYZ, what we're going to do is set them equal to each other. So we're going to go 4x minus 10 equals 5x minus 5, and then solve for x. Because if these two angles are the same, it will create an isosceles trapezoid. So in order to solve for x, we're going to subtract 4x to both sides, and we're going to get negative 10 equals 5x minus 5. Or sorry, it's 4x plus 10. It's 4x plus 10. So we're going to go minus 4x, and we get 5x minus 5, and basically it's equal to 10. And then we're going to add 5 to both sides. Wow, I really messed up. So we subtract, let me start over. We have 4x plus 10, angle WZY equaling 5x minus 5. And then we're going to subtract 4x to both sides, and we're going to get 10 equals x minus 5. And then we add 5, and we're going to get 15 equals x. So x equals 15. So we just found x so that wxyz is an isosceles. Essentially, if we plugged in 15 into 5x minus 5 and 15 into 4x plus 10, it would equal the same angle. Again, all I did to determine that this was an isosceles is if we're giving the two angles that are the base of this trapezoid, we can determine if it's an isosceles trapezoid by setting them equal to each other and then solving for x. And if the angles equal each other, that means it's an isosceles trapezoid. So that concludes the independent practice for Unit 9, Lesson 5. I'm going to post it right now to YouTube, and then I'm going to do the unit review today. Thank you so much. Have a great day, and keep working hard.